We are looking at how to find the inverse of a number in the group of units, right, or u of n, right. So we need some prerequisites for this. So I'll first define how to find GCD of two numbers. So our first aim is uh, how to find GCD of AB. Okay, how to find it? Okay, for that we need to go through one algorithm, which is division algorithm. Division algorithm. Okay, so what is division algorithm? So let A and B be integers with B is positive. Okay, then there exists unique integers Q and R with the property that A can be written as B times Q plus R, where R is lies between B. So it will not achieve B. So the remainder is goes up to 0 to B minus 1. Okay, 1, 0, 1, 2 up to B minus 1. So this is what they are telling. Okay, so let's see some examples. So they are telling given A and B, we can write that, right? So let's take A equal to 3 and B equal to 2. Then what do you have to write? You have to write 3 as BQ, right? 2Q plus R, right? Where R has to be uh, less than or equal to 1, because that is B minus 1. So how do you represent it is uniquely? So easily you can see 3 can be written as 2 into 1 plus 1, right? So this is your Q, right, and this is your R, and this is your A. So it is done, right? What are those Q and R? That Q equal to 1 and R equal to 1. So it satisfy this condition also. Okay. So let's take another example. Let's take A equal to 1 and B equal to 3. Okay. Example 2. Then what happens? You should write 1 is equal to 3Q plus R, 0 less than or equal to R less than or equal to 2, right? This is you can do. You can see that the only way to write this is equal to 3 times 0 plus 1. So who is Q here? Q is 0 and R is 1. So that also satisfies this condition. Okay. So whenever B is greater than A, this is the only way. You should write A is equal to B times 0 plus A. Right. And this works because the remainder A is less than B, or less than or equal to B minus 1. This is your remainder. So it's a special case. Third one, we have no given any restriction on A. So A can be negative number also, right? So A equal to minus 3 and B equal to 4. Then how do you represent minus 3 equal to 4Q plus R, and R is up to 3. So you need to choose wisely, right? So what is Q and R like that? So Q can be anything. They are integers, need to be integers. So if you choose Q is equal to minus 1 and r is equal to 1, we are done. Let's see. So it is minus 4 plus 1. So 1 minus 4 equal to 3. So it serves the purpose. R is between this. So we are done. So this is division algorithm. Given A and B positive, you can always write A is equal to BQ plus R. Q and R are unique integers. Okay. And why it is useful? Now, how do you find GCD? So to find GCD, so we need an algorithm. Okay. So GCD of two numbers, A greater than B. Assume one of them is greater than or equal to B. Okay. If A equal to if A equal to B, the GCD is A only. So there is no, that's not interesting. So let's take A greater than B. Okay. Then what we are going to do is we write A is equal to BQ plus R, right? And then what we do is we write B is equal to, okay, some, the apply division algorithm with the B and R. So it is some Q1 plus R1. Next what we will do is we write R is equal to R1 Q2 plus R2. So finally you end up a position where R k is equal to 0. If you write like that, then this R just before the 0th remainder, this is your GCD. So I'll illustrate with example. Okay, and we also write a method to write it. Okay, so let's find out GCD of 33 and 12. Okay, GCD of 33 and 12. So what you want to write is you write Q here, A here, B here, and R. Draw a table. Okay. So first case, if 33 equal to BQ plus R, what is your B? B is 12, right? What is the remainder when you divide by 33? If you divide by 33 by 12, you get remainder 9. So what is the corresponding quotient? 2. So what is the meaning of this? The meaning is simple. 33 is equal to 12 into 2 plus 9. Okay, this is your B, this is your A, Q, R. Okay, I am writing in this table form. Now what you want to do is change this B to 8th position, R into Bth position. So what happens is, here you have 12, B is 9. Then what is the remainder when you divide by 9? So you get the remainder 3. What is the quotient in corresponding? 1. So what is the meaning of this? 12 can be written as 9 into 1 plus 3. Okay, you don't have to write the right hand side, not necessarily. Now position changes. 9 goes to this position, 3 goes to this position. So 9, 3. In this case 3 divides 9, so 0. So it divides 3 times. Okay, so yes. So what happens is remainder is 0, then the remainder before that 0th remainder is your GCD. So what is the GCD? This is GCD of 3 and 33 and 12. Okay, 2 more example I will do, then you will understand. What is GCD of 750 and 900? So write the table Q, A, B, R. What is A? Bigger one you take, 900. This is 750. What is the remainder? If you divide by 750, you get 150. Now change positions. 150. If you divide 150 by 700, it is correct, goes completely. 5 times it is goes. So what is the reminder here? The reminder is, I mean, what is the reminder just before 0? So this is your GCD. This is GCD of 750 and 900. Okay, one more example we'll try. What is GCD of 252 and 105? So write the table Q B R 252 is, what is the reminder? Reminder is 42. Change positions 105, 42. What is the reminder? 21. You can write the quotient also if you want to. 42 you change, 21 you change. 21 divides 42 two times, so 0. So who is the reminder just before 0? So this is your GCD 252 and 105. Okay. Okay. Now how this is um, helpful? So this algorithm to find out, we are coming to our problem. Suppose we want to find out, you know that uh, if you want to find out 9 inverse in u10, you've seen that 9 inverse is 9 only in u10, right? If you revisit the last lecture you can see. So u10 contains how many elements? 1 3 7 9. Okay, so what is the idea is, we know that GCD of 10 and 9 is equal to 1. Okay, now who is going to be the inverse? That element x which is congruent to 1 mod 10. This is why this x we need to find out. Okay, so what we are going to do is, we need to write uh, 10 in terms of division algorithm. So division algorithm tells you that 10 is equal to, when you divide by 9, the remainder is 1. Okay, so 10 is equal to 9 plus 1. Okay, now if you, so what is the quotient here? So this is your B, this is your A, this is a remainder. So if you proceed the division algorithm, 9 should be written as 1 is divisible by, so what is the quotient? 9 plus 0. So 1 divides 9 times, right? So the GCD is 1. GCD is 1. So what we can do is, 1 can be written as 10 minus 9, or it is in Bessout's identity form, 10 into 1 plus minus 1 into 9. Okay, so what is Bessout's identity tells you, right? The same thing. So 10 into W plus 9 into Z. So this Z is going to be the inverse, right? That's what we have seen in the proof. So who is the coefficient of 9 in Bessout's lemma? That is going to be the inverse. So Z equal to minus 1. What is minus 1 mod 10? Minus 1 is not inside the reminders. So you add 10 to minus 1. So what is you get? 9. So 9 is belongs to u10. 9 going to be the inverse. You can see 9 into 9 is 81. 81 mod 10 is equal to 1. So 9 into 9 equal to 1 in u10. So I'll explain this with one more problem. So find 8 inverse in u21. Okay, so it is very clear that, so we have to check whether you have to find the inverse of 18 U21. So GCD of 21 into 21 and 8 is equal to 1. So how do you, so that you know, right? Or you want to find out whether you have to check whether the GCD, what is the GCD of 21 and 8. So what you will do? You have to follow the algorithm I have just told. So you can take this. So what it is tells you, A is 21, B is 8. What is the reminder? Reminder only one time it will go, right? So the reminder two time it will go. The reminder is Q is that. Now you change the positions. It is 8 will come here, 5 will come here. How many times it will go? One time. Reminder is 3. One time only it will go. Now position here. So this is 5, this is 3. How many time it will go? Only one time. Reminder is 2. Now 3 goes here, 2 goes here. What happens? Only one time it will go. The reminder is 1. Now 2 goes here, 1 goes here. 1 divides 2. Only 2 times it is goes. So who is just before 0? So GCD is 1. So that is okay. 21 and 8. So GCD is 1. Now our aim is, if GCD is 1 by Bessel's identity, what it is telling? There is W and Z, so that 1 is equal to W plus 8Z. So if you can write 1 is equal to W 21 W plus 8Z, then this implies 8Z minus 1 is equal to 21 into W, or simply 8Z is equal to 21 mod 8Z is equal to 1 mod 21. So Z will be the, Z is actually the 8 inverse. So the task is, how do you write this, like how do you write 1 is equal to in this form? Will this help? Will this idea will help? Okay. So we have to backtrack what we have done in division algorithm. That is the idea. So how do you backtrack? So simply I should recall this to the next page, then you'll understand. Okay. So we will write the same thing here. Okay. So A, B. Yeah. So what is the meaning of this? This is equal to what? A is 3 equal to 2 times 1 plus 1, right? What is the meaning of this? 5 is equal to 3 times 1 plus 2. What is the meaning of this? 8 is equal to 5 times 1 plus 3, right? And this is equal to 21 equal to 8 times 2 plus 5. Okay. So we need a linear combination containing 21 and 8. So we are backtracking like this. So listen carefully. So you have 3 is equal to 2 plus 1. So from this you will get 1 is equal to 3 minus 2. Now left hand side is safe. One side 1 is there. Right side you have to make it a linear combination. Now go to previous thing. How do you write 3? So 3 you can write, or 2 you can write as 5 minus 3. Okay. So 2 you can write as 5 minus 3. Okay. Now 5 minus 3 you can write as 8 minus 5. Okay, so this is, you can write as 8 minus 5. Okay, now 5 is actually introduced, right? Okay, now we have to introduce 8. 8 is what is 5? 5, how do you write 5? 5 you can write as 21 minus 16. Okay, so 3 minus 5 minus 8 minus 21 minus 2 times 8. Okay, so this much you have. So you have now 8 and 21 in your hand. So we'll try to expand this one by one. So 3 minus 5 minus 8 minus 21 plus 2 into 8, like this. So this is equal to 3 minus 5 minus 8 plus 21 minus 2 into 8, right? So now this is equal to 3 minus 5 plus 8 minus 21 plus 2 into 8. Okay, so right. So now it is not completely 5 and 8 and 21. We have some fellows here, this 3 minus 5. So 5 you can again you should again write it as, so first 3 you can write as 8 minus 5. So you can write 3 8 minus 5. Okay, uh, 8 minus 5 minus 5 plus, bracket is not needed, 8 minus 21 plus 2 and 8. So how many 8 are there? 1 2 2. So 4 into 8. Okay, minus 21 minus, you have 2 into 5, right? Minus 10. Again what you have to do is you have to convert it into 21 and 8. No, so 5 you can replace by 21 minus 16 again. So 21 minus 2 into 8. So when you expand, 4 into 8 minus 21 minus 2 into 21 plus 4 into 8, you can write. So totally then what you get is how many 8 are there? There are 8 into 8, right? Minus 3 into 21. Okay, minus 3 into 21. So now you return everything in terms of 1 in terms of that. So what is your w? How did you write it first? So z. So z is equal to 8 and w is equal to minus 3. So what is the inverse? So they are telling 8 is the inverse. So let's check. 8 into 8 is equal to 64. 64 mod 21. So how many times 64 goes in 21? I think I think 3 into 21 is equal to 63, right? So the remainder when it is divided by 64 is 1 in mod 21. So what you got is 8 times 8 is equal to 1 in u21. So what you can say, inverse of 8 is equal to 8. So this procedure, it's just converting every number into what we want. So that's why it is a little long, but it is fine. But it is still worthy of uh, than writing the complete to 21 numbers and making the table. Uh, Even the space is not there. Okay, so this will be easy. So try yourself another number. For example, try uh, inverse of in u of uh, 17 or something, because you know that the GCD of, because both are prime numbers, equal to 1. So try to find this. So use division algorithm, do that. Try to write 1 is equal to 13z plus 17w, and this z will serve you as a 13 inverse. Okay, that's the idea. Okay, so next class we'll start another interesting group, which is called permutation group. Okay, thank you.